Hello friends, in the sequence of DBMS schedules, we are now in this lecture supposed to read about serializability. So let's see firstly what is serializability. A schedule S of n number of transactions is serializable if it is equivalent to some serial schedule of same n transactions. That means if a schedule S is said to be serializable, that means it is supposed to be equivalent to the same n transactions in a serial schedule. So let's understand with the example. First type of serializability is conflict serializable schedule. Again, if it is conflict equivalent to its serial schedule, that means every conflicting operation need to be equivalent with its serial schedule. So let's understand it with the help of this example. Here we have schedule S1 and schedule S2, which is known as serial schedule, or the we can say S2 is the serial equivalent schedule of S1. So let's see with what are the different transactions and operations in S1. There are two transactions in S1. T1 is having read operation of A, write operation of A. Then subsequently read operation of A and write operation of A is supposed to be executed by T2. Then after T1 executes the read operation of B and write operation of B, which is being followed by read operation of B and write operation of B by transaction T2. Now, if I need to say this S1 schedule is conflict serializable, then I need to check whether the sequence of the conflicting operations are supposed to be followed in the equivalent schedule of S1 when that schedule is a serial schedule. So S2 is nothing but the serial equivalent schedule of S1. So let's see firstly order of conflicting operations in S1. So here reading of A by T1 transaction is being followed by writing of A by T2 transaction. Read of A by T1 transaction is followed by writing of A with T2 transaction. Next, writing of A is being followed by reading of A of T2 transaction and as well as writing of A of T2 transaction. That means writing of A in T1 transaction is being followed by writing of A and reading of A of T2 transaction. Then next conflicting operation is reading of B is being followed by T2 transaction, which is performing the write operation on B. So read operation of B in T1 transaction is supposed to be followed by write operation of B in T2 transaction. Then next, again writing of B in T1 transaction is being followed by reading of B in T2 transaction and as well as writing of B in T2 transaction. So writing of B in T1 transaction is being followed by reading of B and writing of B in T2 transaction. So these are the sequence of conflict or the critical operations in S1 schedule. Now let's see if the serial equivalent schedule of S1, which is here mentioned as S2, is having the same sequence. So if we are supposed to make the schedule serial, then all the T1 transaction operations are arranged in a sequence which is being followed by all the operations of T2 transactions in a sequence. So let's see if the same sequence is being followed by its serial equivalent schedule. Here, if R1 of A, that means reading of A in T1. So reading of A in T1 is being followed by writing of A in T2. Yes, this is matched. Then writing of A in T1 transaction. Writing of A in T1 transaction is being followed by reading of A and writing of A in T2 transaction. Yes, both are matched. Then reading of B in T1 transaction is being followed by writing of B in T2 transaction. Yes, there it is. Then writing of B in T1 transaction is followed by reading of B and writing of B in T2 transaction. Yes, there it is. So here we can say this S1 is conflict equivalent to S2 schedule. I hope this is pretty much clear with you guys that what is conflict serializable schedule. Okay, so let's see how we can test for serializability. Testing for the serializability is done with the precedence graph. Now, what is precedence graph? Let's say if S be a schedule, we need to construct a directed graph which is known as precedence graph. Is in this graph we are having the vertices and edges as the vertices or the nodes are the transactions and edges are being defined by the operations. Now what type of operations define those edges? Let's see firstly algorithm for the edges. Create a node for each transaction. As we have already seen, the transaction represent nodes. Then now draw a directed edge Ti to Tj. When we are supposed to draw a directed edge? If Tj reads a value written by Ti. That means write operation is supposed to be executes by Ti transaction, which is supposed to be read, the same data item supposed to be read by the transaction Tj. Second condition, draw a directed edge Ti to Tj if Tj writes a value which has been read by Ti. That means Tj is supposed to be executed a write operation on the same data item for which Ti has executed the read operation. Next condition, draw a directed edge Ti to Tj if Tj writes a value after Ti writes it. That means the write operation of Tj is supposed to be executed before Ti writes it. So these are the three conditions when we are supposed to draw a directed edge Ti to Tj. That directed edge is drawn when a conflict operation occurs. That means for every conflict operation there has to be an edge, and that edge should be directed one. Now, a schedule is conflict serializable if graph is acyclic. So, the graph we are supposed to design or draw, that graph is supposed to be acyclic. That means no cycle should be present in the graph. Then only we can say that schedule is conflict serializable schedule. Let's understand it by the example. As we can see here, we are having three transactions T1, T2 and T3, and some of the operations are there. T1 reads A data item, T2 reads C data item, then T1 reads C data item, then T3 reads A data item, reads B data item, write A data item, then T2 write B data item, read B data item, write C data item and write B data item. So let's construct the graph using the same algorithm which we have seen. First, let's create the nodes T1, T2 and T3. So we are having three transactions, so we have created three nodes. Now for the edges, Let's see if T1 reads a data item which has been written by another transaction. Ti reads a data item which is written by Tj, or I'm sorry, as per the algorithm, if Tj reads a data value which is written by Ti, so edge would be from T1 to T3. That would be the directed edge for the data item A. Next, what we are supposed to see, that the reading of C is being followed, reading of C data item is being followed by the writing of C data item by T2. So again, we can draw a directed edge T1 to T2 for the data element C. Next, for T2, in T2, what we can say is the reading of data item B. The reading of data item B is being followed by the reading of data item B by another transaction. Then from T3 to T2, from T3 to T2, I'm sorry, that is for reading of B data item, the writing of B data item is there. So it read a data item B which already being which is being followed by the writing of data item B in T2 transaction. So here the directed edge would be from T1 to T2. Sorry, from T3 to T2. That would be for data item B. So here, as we can see, a directed edge from T1 to T2, a directed edge from T1 to T3, and a directed edge from T3 to T2. So it has no cycle. I once again repeat that from T1 to T3 for A is reading of A is being followed by writing of A. So from T1 to T3 for data item A, a directed edge is there. For T1 to T2, reading of data item C is being followed by writing of data item C. That's why directed edge from T1 to T2 is there for C data item. Then in T3, reading of B is being followed by writing of B in T2. That's why from T3 to T2, a directed edge is there for data item B. Since this precedence graph what we have drawn is containing no cycle at all, that means we can say that these transactions are serializable transactions, or this schedule is serializable schedule. Now let's see another example. Here we are also having two transactions T1, T2 and T3 which are containing multiple operations. So let's see again. Let's draw the edges T1, T2 and T3. Let's see if we can construct an edge from T1 to T2 as T1 is writing a element A which is being read by T2 transaction, which is being followed by reading T2 transaction. So here we can draw a directed edge from T1 to T2 for the data item A. Then after, let's see for data item B. Data item B is being read by T2, which is supposed to be written being followed by the write operation of T3. So it has been already read by the T2 transaction, which has been written by T3 transaction later on. So here we can draw a directed edge again from T2 to T3 for the data item B. Then for the data item C, let's see. In T1, write operation for the data item C is there, and in T3, write data operation of C data item is here. So T3 write operation is being followed by the T1 write operation. So again, from T3 to T1, a directed edge for the C data item is supposed to be drawn. Now since here we can see T1 to T2, T2 to T3, and T3 to back T1, we have directed edges. That means here is the cycle forms. So here graph is not acyclic and cycle is there. So here we can see that it is not a conflict serializable schedule. Okay, so now we are done with the serializability test. Now the second type is the view serializable schedule. So two schedules are view serializable if, let's see all the three conditions. For each data item A, if Ti reads an initial value of A in schedule S1, then Ti must also read the initial value of A in S2. That condition means in schedule S1, if any transaction Ti reads first time read the data item A, then the same transaction number must also read the initial value of A in S2 schedule. That means in both of the schedule, same number of transaction must read the initial value of A. Second condition, if Ti executes read operation of A in S1 and value is written by Tj, that means WA operation is being executed in Tj, then Ti in S2 must also read value of A written by Tj. That means if in S1 schedule one transaction executes read operation on A, in which or for which data item A, the write operation is being performed by another transaction in the same schedule. So in S2 or the other schedule need to be follow the same order of reading of A in Ti and writing of A in Tj. Then the third condition, for each data item A, transaction that perform the final write operation in S1 must also perform the final write operation in S2. This condition means for data item, for a specific data item, finally write operation is being performed by whatever transaction number in S1, the same transaction number should perform the final write operation on the same data item in S2. So let's understand all these three conditions with an example. Here we are having two schedules, S1 and S2. If T1 is being followed by T2, this is the order we are supposed to follow in our example. So let's see if these two schedules are view serializable or not. Is in T1 transaction, the write operation is being followed by the read and write operation in T2, or you can say the a read operation is being followed by read operation. Look, the first condition says if Ti reads an initial value of A in schedule S1, then Ti must also read the initial value of A in S2. So T1 reads the initial value of S1 for A. So in S2, the read operation of A should be done by T1. So first condition, we are being satisfied here. The read operation of B is being done by T1 Here also the read operation B is done by T1. So we have done with the read of any data item for the initial read. It has been checked for both of the schedule and the condition is matched. Let's go for the second condition. If Ti executes read of A in S1 and value is written by Tj that means Ti reads the value of A and value is written by Tj, then in S2 also Ti must read a value which is being written by Tj or T2. So here in S1 T1 reads A which is being written by T2. Here also T1 reads A which is being written by T2. So the second condition matched for the A. Now let's see with the B. T1 reads B which is being written by T2. Here also T1 reads B which is being written by T2. So for both the data items, second condition also matches. Now let's check for the third condition. For each data item A, transaction that perform the final write operation in S1 must also perform the final write operation in S2. So let's see. The final write operation for A is being performed by T1. Sorry. Here, final write operation of A is being performed by T2. So here also the final write operation is being performed by T2. So third condition for A data item has been checked. Now the final write operation of B is performed by T2 and here also the final write operation of B is being performed by T2. So for the both data items A and B, all the three conditions are being checked. So we can say S1 is view equivalent to S2 or view serializable to S2. That means S1 is equivalent or view equivalent to its serial equivalent schedule. Now, one point is supposed to be noted down here that every conflict serializable schedule is also the view serializable, but vice versa is not true. This point, guys, please note it down very carefully that every conflict serializable schedule is also view serializable, but every view serializable schedule is not always a conflict serializable schedule. So I hope we are pretty much clear with the types and serializability concept for the schedule, and also we have done the testing of serializability with the serializability precedence graph. So we'll coming up in the next video. Take care.